we are going to be working through the sine rule. And last time we looked at a situation where you could end up with two distinct triangles, right? So there was some situations where the triangle had enough room for you to have the angle that you get, which is always going to work, right? And then maybe a second bigger one, right? So one of them was 30 and the other one might be 150, but you could only use the second one if there's enough room. So what I'm getting at is, imagine you had the triangle with various numbers, and this was 20 degrees, and you went hunting for that one, and the answer was 30 degrees. There is another possibility, and that is that it could be 150, right? And you notice the connection between this and this is that they also add up to 180. Now, in this case here, that works because there is enough room here, isn't there? 20, there is enough room to get 150. But in a different world, can you imagine that this angle here was 80? Well, 30 is always going to work, but the 151 can't work if that's 80 because it's too big, right? So when you're looking for a missing angle, have a look at the second possibility and see if it's going to work. It's pretty rare, right? I think it only happens twice in the homework that you're going to get two, and we covered one of those situations. Now we're going to cover a new situation, and that is a triangle where nothing works. In other words, there is no solution. Right? So I think there's only one example of this. I might be proved wrong, but I think there's only one. At least in the one I'm looking at. This is version 12, and I'll draw a nondescript triangle ABC, and this is little a, this is little b, and this is little c, and we're told that little a is 21 units long and little c is 45 units long, and angle A, I know it doesn't look like it, but it doesn't really matter because this is just a triangle for putting numbers into. That angle there is 127. And we are going to solve the triangle. So we're going to find out that this triangle cannot exist in real life. In other words, there is no solution to find, but now we have to find out, how that's going to happen. According to our kind of process, shouldn't I be looking for any other angles I can get? And the answer is no, I can't find any. Now I'm going to check off what I know, or I'm going to try and find out. I know that guy, I know that guy, I know that guy. Would you agree in this particular combination then, I should be trying to find angle C? Does that make sense? I knew these three, so that's kind of the candidate. So it's going to be the outside too. So sine A over little a, sine C over little c.
I think you have your triangle mislabeled.
Oh, I hope not.
Because you have
little
angle
a.
C
Oh,
side B.
shooting space. Well caught. Well caught. Why I did that? Good news is I can keep everything else the same, right? So that is little b and that's little c. So too busy thinking about it not working. So it's a sine 127 over little a, which is 21. Sine of c over little c, which is 45. Cross multiply, nothing too surprising, pretty standard. Divide both sides by 21. And then we would find the inverse sine, and that will give me my angle. And everything looks pretty much normal. And then you've got your calculator. Make sure I'm in degrees, which I am. And then I'm going to do inverse sine. So I'm going to find the angle that gives you that guy. And I better see some kind of error at the end of this. Do you see it? Now you might say, why is the calculator keeling over and dying and saying error? I'm now going to calculate what that is equal to, and it's going to be bigger than 1. It's 45 times the sine of 127 divided by 21. And do you see that that is 1.7? And remember, you can't get inverse sines bigger than 1 or less than -1, right? There is no angle in your unit circle, right? There's going to have an x coordinate of 1.7 or a y coordinate of 1.7 for that matter. So dne, which makes answering question 12 dead easy, because angle B is dne, angle C is dne, and little b is dne. Since the triangle doesn't exist, none of those angles and sides can exist, right? Because if they existed, the triangle would exist, right? So when you do a calculation, if you go through the process correctly and you get to this step here, and the calculator says that there's an error, that calculator's telling you that triangle is physically impossible to draw, right? With the numbers that you're given, right? And you might say, but you've drawn it. Well, really, if you think about it, have I really drawn it? I mean, look at the size of that. Shouldn't it be pointing away over here? Right, if I was drawing it accurately. So no. Can you imagine a triangle that looked like this? And this side here just wasn't long enough to meet up. Can you imagine a 17 and a 2? Won't they never come down and make a triangle? That's what a triangle that doesn't exist kind of looks like. You know, if you put the sides or the angles, the combinations just don't work, right? There's no way that the third side can actually meet up with the other two, right? They're going to be able to kind of miss it in some way, and it flips by it, you know. Are we okay with that idea that there might be a triangle with no solution? Okay. Now, what's left? We have got, I like these ones, the puzzles, the applications. So I'll start with 14. And I'll start a new page. There's a little mark there. It's just going to distract me. So it looks something like this. And when you have a shape that's made of 2 or more triangles, we have to change a little bit the way that we describe the angles. So this angle here, right, this one here, couldn't I just call it A and everybody knows what angle I'm talking about? Would you agree that this angle over here, if I just called it B, everybody would know what I was talking about, right? But if I say angle D, do I mean that 180 degrees? Probably not. I'm probably talking either about this fella here, right? Or that guy there. And so we can't just call it angle D because you don't know which one I'm talking about. Am I talking about the one on the right-hand side with the circle? Or when I talk about angle D, am I talking about the left one? So the notation that we use is 3 letters. So if you want the circle one, you can call it CDA, or you could call it EDC. Are you comfortable about that notation with 3 letters when it's not clear what you mean when you say angle D? Can you see that that one makes it clear? Now, what about the little guy on the other side, right? So that's the angle that looks like this. What about the angle that looks like a little asterisk, the one on the left-hand side? What would we call that guy? And there's 2 names, both are correct. EDC. And what's the other one?
BDC.
Oh, I've just done BDC. Oh, you
Oh.
said C. I think he said, I wrote the wrong one down. He said that one and that was the other one, right? I wouldn't push this rule because it really isn't a rule. But shouldn't you probably do them in alphabetical order if there is an alphabetical order to do them in, right? But if there's not, then I wouldn't say that's any better or worse than that one. So we've got that little hiccup solved, right? That sometimes you have to call an angle with 3 letters rather than 2. Now, they've got in the picture things called U, V, and W. I'm not going to use the U, V, and W. They are a distraction. I'm just going to put in what they tell me. They tell me that U and V are the same and they're 22. And that makes this guy 22 and it makes this guy 22. And then they tell me W is 28 and that makes this guy 28. So basically, that's the picture. Now, it's much nicer if they just put the answers in, but because of WebAssign wanting to randomize the numbers, this way allows them to, give each person a different version of that same question. Now, we are being asked to find 2 things. The first one they want us to find is angle BCD. And the second thing they want us to find is angle C, get this right, DCA. Okay, so let's focus on this one, angle BCD. So BCD, is that right? DCA. That is dumb. That is very dumb of them, in my opinion. It's okay to ask for these angles, but I think they should have asked them in a different order. Right? But nonetheless, let's work through the question. I am going to find eventually BCD, which is, put it in green. We are going to find this angle up here, right? Eventually, but not yet. I am going to find this one here first, right? Now, once I find that one, then we'll go looking for this one. So I guess the moral of the story is, find the angles in the order that's most appropriate. So I'm just going to draw this triangle only, so there's less distractions. This angle here is 30 degrees. This side is 28. This side is 22. And this is called D, and this is called C. So this will be little d, this will be little c, and this will be little a. So my sine rule is going to be sine A over little a, sine C over little c, and sine D over little d. Are you comfortable that you don't always get ABCs when you do sine rules, right? 3 angles, 3 sides. Now, I want to find a missing angle, that one. Let's see if it's possible. And if not, we'll find what is possible. I know you, and I know you. So which angle will I actually get?
A D.
Okay. So it looks like to get the one that they asked me for, don't I have to find this one first? But once I know what this one is, and I already know that's 30, won't getting that one be easy, right? So when you get a puzzle, you don't always get what you want right off the bat. Don't you have to sometimes get something else and then get what you want, right? So it's a kind of, I've even seen questions where you have to get this, that leads you to that, and then finally you get what you're really after, right? So in this case, I'm going to use the A and the D. So that's going to be the sine of 30 degrees over 22 is the sine of D over 28. Let me double check that. Yep. If you do the cross multiply, 22 times the sine of D is 28 times the sine of 30 degrees. You divide both sides by 22, and then you get D, and that's going to be the inverse sine of this mess. I think it's reasonable to assume that these are right angle triangle, or these are triangles, I should say, and that there's really going to be one answer. So I'm not going to look for a second one, because I'm going to assume that there is only one answer, or the question really wouldn't be fair. And the answer to 1 decimal place is 39.5 degrees. So I know this guy is 39.5 degrees. Now, the angle that I really wanted was that one, right? And so, because I'm not good at doing things in my head anymore, you add these together and you get 69.5. And doesn't that tell me then if you take that away from 180, that I get 110.5 degrees. And now I know this angle here. Why is that there? Oh, come on, that's not right. I get caught up there by making a bad assumption. Didn't I assume there was only one answer and it wouldn't be fair? There is one answer, but it's not 39.5, and I should have looked at it. Even in the badly drawn picture I've got, does that look like it's 39 point anything? Isn't it the other one is the one answer, right? There is only one answer, but it's not 39.5. What is that guy?
140.5.
Well, I'm glad I caught myself. Now, I know this is 30. I know this is 140.5. So I now know this is 170.5. So this little guy here is what's left, and that is 9.5 degrees. And why I'm quite annoyed at myself. Shouldn't you just use common sense when you're doing a question? Right, so when I looked at that, I should have said, 39? What on earth do you think that's the right answer? Right? Can you see it's obviously big? But we got that little hiccup. So my picture here, which looks a little bit more of a mess, this angle in here is 9.5 degrees, and this big angle is 140.5 degrees. And if any of you are wondering, how do you get from the calculator answer to this one? Don't you just take it away from 180? Right, so whatever answer the calculator gives you, right, 40 degrees, the other choice would be 140, right? If one of them was 22 degrees, the other would be what's left when you take it away from 180. So we now know 9.5 degrees. And BCD is coming up. BCD is this guy. And I am not going to use the sine rule. I am going to use some other tricks. Would you agree that this is a straight line? And this side is 140.5. How come I know that's 39.5 without doing any sine rules?
Because a straight line's 180 degrees, so you subtracted the right side.
Yep. Are you all comfortable with that? Now I'm going to make another answer without doing the sine rule. I'm going to say, and that guy there is also 39.5. And I didn't need to use the sine rule to do that, although I could have if I wanted to. How can I get away with just saying that answer as well? What's the clue?
Because both of the sides are 22 units.
Yeah.
So they have the same exact degree.
Yeah. That has a funny name, that triangle. It's called isosceles that nobody knows how to spell right. Right? Correct. And now I can get the one I was after. You don't need to tell me the answer, but if you can do that in your head, great. How would I find the last little angle? Ignore this guy. That little angle there.
Add them up and subtract from 180.
Right. And I believe it's 79 when you add them. So doesn't that leave 101 for the missing angle? I'd be comfortable with that. So we did get the two angles, but didn't we have to go hunting for them, right? It wasn't a single calculation. It was find this and then find that. And then we used all sorts of properties to do with triangles and straight lines to get the other angle. That's why I like puzzle questions, because they're never quite the same. So here's the next one, 15. At least a version of 15. Straight line. Somebody going something like that. Oops, a bit further, something like that. Got a guy going like that. Somewhere about here, you've got another guy going like that. This is B, this is D, this is A, and this is C. And they tell me that this side here is 16. They tell me that this side here is 16. They tell me that this angle over here is 40 degrees. And they tell me this angle in here is also 40 degrees. And we're being asked to find a side. So when they give you two letters, it means it's a side. And when they give you three letters, doesn't it mean it's an angle, right? So we are being asked to find this guy. So before I start playing about with the sine rule, which eventually I strongly suspect is going to happen, let's see if we can find some other things first. Since I'm interested in AD, shouldn't I be focusing on, for want of a better word, this right-hand side triangle? But there's a lot of information missing because I only know a side and an angle. That's not enough to get started. So let's hold that thought and focus on what you might be able to write down over here. Now there's a big clue. They've done that again.
Wouldn't angle BCE be 40 degrees?
Would you all agree? Isosceles triangle, two sides, two angles. Remember, two sides same, two angles the same, which makes this angle doable now. How big is that one?
100.
Now, if this is 100, I'll change color now. How much is that one?
80.
And if this is 80, how much is that one?
60.
60.
Yeah. Did you see it was like a chain reaction, wasn't it? Like A got you, B got you, C got you, D, you know, boom, 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 all the way down, like dominoes falling. Now, I have everything I need, and I'm going to, just for visual purposes, draw the triangle that I'm interested in. I'm now interested in only that triangle because they're asking me to find AD. And in that triangle, I can put in 80 degrees, 60 degrees, trying to read my own writing here, 40 degrees, and one other thing, I know that's 16. So this triangle, that guy's little a, that guy's little c, and this guy here is little d. Is there any triangle, any angles I can find? Nope, I got them all. So sine A over little a, sine C over little c, sine D over little d. Are we good? Now, I know all the angles, so check those off. And I know little a. Which one do I pick? C or D? Based on what they asked us here.
D.
Now, I didn't
C.
catch it. Is that what you said, C? Yes. Right? We want AD, we want little c. So hopefully that's what you said, right? You agree now? That's the two. So the sine of 60 degrees all over 16 is the sine of 40 degrees all over little c. C times the sine of 60 degrees is 16 times the sine of 40 degrees. So little c will be 16 times the sine of 40 degrees all over the sine of 60 degrees. And we're pretty much done. 16 times sine of 40 divided by sine of 60. And the answer I get is 11.88, which is exactly what they say it is, to 2 decimal places. So you can't really tell, but originally wasn't that picture lacking an awful lot of sides and angles? And we had to go hunting for everything that we could get. But once we figured that out, we were good. I definitely want to do 19, but I want to make that my last one. So I'll do 17 first, and then I'll do 19. So here is a river. And there's a guy here at A and a guy here at B. And there's a little picture that looks something like this. And this is called C. And this angle here is 82 degrees. And this angle here is 52 degrees. And this here is called X feet. And they describe X as being 300 feet. So I guess I should just have written down 300. And we're being asked to find AC. So we're being asked to find the distance from A to C. I really have pretty much a reasonably, I think, straightforward one here. Is there any angle I can fill into that triangle? And if it helps, sometimes it's better just to have the triangle and not to have all the extra Your owner is stuff going round. So that's 300, right? That's a little a, that's a little b, that's a little c, right? Is there any angle I can find the size of that's not already in that picture? Can I find the size of any angle in that triangle?
Let's see.
Yeah. If you add them together, it's what, 100 and... So I believe that makes this 46. Does that seem reasonable? 52 and 82 is 134. What's left from 180? 46 is left from 180. Bear in mind, you're after AC. So AC is really little b. Agreed? AC is the same thing as little b. So sine A over little a, sine B over little b, sine C over little c. Now, that's the only thing they're going to ask. I'm going to ask a different question after this. So let's see. I know angle A, check, check, and C. I know little c, and I'm being asked to find little b. So it's pretty obvious. Those are the pairings that I'm going to use, B and C. So that's going to be the sine of 52 degrees over little b is the sine of 46 degrees over 300. And little b, well, you take 300 times the sine of 52 degrees and you divide it by the sine 46 degrees. 300 times sine of 52 divided by the sine 41. And the answer is not right. So what did I screw up? Is it 82 and 52? 82 and 52? 134? 46? Yep. 300? Yep. 300?
I finished the problem and the answer is 329 approximately.
Yes, that's the right answer. So why am I not getting that?
I assume you're in radians.
Oh, 46 and I typed in 41. I got it. I wrote in the paper and then I didn't see it. There we are. That's the right answer. Never write halfway between two pieces of paper. There. So we now know that this side here is 329 feet. And that would be the end of the question. But it's not the end of, excuse me, it's not the end of the question for me, because I'm going to put in another question. Now that I know that this side is 329 feet, wouldn't you like to know how wide the river is? I think knowing how wide the river is probably more interesting than the distance that A to C is 329 feet. So this is how we're going to do it. Would you agree that that distance there makes a right angle? And isn't this enough to do Sohcahtoa? I want to know that red distance. That's how wide the river is. So From that angle's perspective, this is not the sine rule. From that angle's perspective, this is the opposite, and this is the hypotenuse. Great. And according to SOHCAHTOA then, the sine of 82 degrees is the opposite divided by the hypotenuse. And so the sine of 82 degrees is the opposite over 329. You do a little cross multiply. The side I'm calling the opposite is 329 times the sine of 82 degrees. So 329 times the sine of 82 degrees. And that ends up being roughly the nearest whole number, 326 feet. So can you imagine in the olden days, you were on one bank of a river. What you do is you find a fixed point, like a tree, right? A big tree that looks different from the others, right? And you look at it from over here, right? And you measure, okay, that's the bank, 62 degrees. And then you walk a bit and then you go, oh, 52 degrees. Eventually, if you go through all this process, can't you find out how wide any river is? Without having to actually, I'm not sure, how would you do it even practically? See if you got in a boat with a long tape measure, wouldn't it be really hard to get the width of a river? First you'd have to have 325 feet of tape, which I don't think is very realistic. But I like that question. I wish they'd done a part B. Well, we have one last puzzle question to do. And we're keeping, I guess, the best till last. And let me complain for you that question 19 could have been drawn, should have been drawn a lot nicer than it was. So let me show you the picture I'm talking about, and then I'll try and explain what's going on, because it's really got a lot of hidden information in it. There. There's some kind of hill with a big, radio mast on it. This angle here is 58. This angle here, alpha, is 11. They should just have told you it was 11, but they keep changing it for the question. And we are being asked to find the length of that red wire. Now, when you look at that, you might say, well, that's not enough information. Well, it isn't, because they tell you one other thing, which I'm going to put into my little picture in a minute. So I'm going to put in a horizontal line. No, one. Let's do it so you can see it there. And I have got a line being the hill. And then at the top of this hill, there's, I can't draw things to save myself. You've got the post. And we're being asked to find the length of that red line. You are told that the hill has a slope of 58 degrees. You're being told that this angle in here is another 11 degrees. And the only other piece of information you've been told is that distance from here to here, at least in the one I was looking at a minute ago, was 200, and it still is. And somehow or other, from this picture, we are going to find the length of that red line. So I'm going to add some extra lines. I'm going to do them in red, I think. I'm going to draw a little dotted line going like this. I'm going to do a continuation of the slope going like that. And I'm going to do another dotted line going that way. And the reason I'm going to be doing all of this is to try and show you that we can actually find that angle. Because once I know the size of that angle, I can then do the sine rule and we're good to go. So that angle in there is my goal right now. Okay. When vertical meets horizontal, don't we assume it's a right angle? So far, so good. Now I'm going to turn into green. How big is that angle? Oh,
30
the whole,
degrees.
the whole thing is 180, and that red bit plus that green bit is 180. But I only want that little piece there.
32,
30.
Agreed. How did you get 32?
90 plus 58 minus 180.
Right, it's the third bit that's left over. Agreed? Yeah. So far, so good. Now, a little bit less obvious. Why is that angle 58? Which it is.
Because it follows the same line as the 58 degrees and it meets up with a horizontal line of 0.
Why is this angle 32?
It's a 90-degree angle.
And I'm not going to ask you why is that 90 degrees, because isn't that a right angle? Guess what? Isn't there only one angle that's missing? The one that I said we wanted to find. Isn't that red one the only one we don't know? How big is that red angle?
-180 minus 32.
Okay, that's probably the way I would do it.
148.
And it's 148. Can you add up everything and take it away from 360 and get that as well? Now that I've found that well hidden angle, I am now going to go back and draw the picture, but this time only the triangle that's important. So far, so good. Now, I'm going to call this A because I want to. I'm going to call this B, and we're going to call this C. And this guy is little c, and this is little b, and this guy here is little a. Is there any angle in that triangle that we can find the size of? We already know 11 and 148, but is there any other angle I can get?
C,
Right. And I'll put a little arrow pointing at it. How big is C?
21.
Check it again. 148 and 11 adds up to 159. So how big is C?
21.
Are you all comfortable with that? Right, let's start moving. Sine A over little a, sine B over little b, and sine C over little c. Oh, in case we've forgotten what the goal was to find that guy, little b. So I know all the sides, I know little c, and I want to find little b. So guess what? We're ready to rock and roll, right? Sine roll has got everything in place. So it's going to be the sine of 148 degrees over little b is the sine of, it's like it's 21 degrees over C, I've lost C, 200, there we go. B times sine 21 degrees equals 200 times the sine of 148 degrees. And then I just need to divide. Here goes. 200 times the sine of 148 divided by the sine of 21. And I get 296 to the nearest whole number, which is, in my question at least, correct. Cool question, right? Picture was totally useless. The WebAssign could have made life a lot cleaner by making that picture a lot more understandable, right? Because it isn't clear. To me, it wasn't clear when I was looking at it, you know, what was what. Okay, Katie,
Yes,
ready?
I'm ready. For what?
Okay. Midnight Sunday. Can you get extensions to anything?
No.
Matthew, when is our final? Our midterm, I should say.
It's on Monday.
From where to where?
Well, as
9
you
a.m.
say,
to 11.
Help them. When does it start?
I'm home.
9 a.m. to
9.
11.
9 to 11. Matthew, aren't you glad I asked you that question? Right? 9
Yeah.
till 11. So don't turn up at class time because you'll be halfway through the midterm, which is not a good idea, right? Okay. I think that's us. Perfect timing.
I was
I'll
looking-
hang about. Yes, Kay.
sorry. For the final or midterm, it says that there's two parts. There's one like in class and then one that's due on
No,
it's not
it's
that.
all going to be on Canvas.
Okay. Because it said in like the
Did I say something different?
something in the syllabus or something. I swear I thought I
Oh,
saw.
I probably changed it to just having simple. The simpler you make it for students, the less stressful. So having it all on Canvas was just simpler.
Okay.
Yeah.
Sounds good.
I did have a question. So
Yes.
I'm not sure if I'm going to be able to stick around for the full meeting tomorrow, but I'm basically already done with the homework anyway.
Yes,
then
tomorrow
it's-
we're revising for the midterm, so there's nothing new going to be happening. So
Okay.
that won't be so serious. Okay, so
Could I
just
still technically
yes.
get my attendance?
You have turned
still-
up. Yes. So say hi before you go.
All right, thank you.
Okay. Any
Bye.
other questions? Bye-bye. Any other questions?
Yeah, when you were doing 19, how did you know to label the 200 where you labeled it? Because when I was
Oh,
doing-
because the question told me that the distance from there to the base was 200.
oh, to like the base of the tower.
Yes, so the bottom of the tower was here, and from there to there was 200.
Okay,
So that was a number given to me in the question.
gotcha. And for the test on Monday, you said it's just gonna be on Canvas, like a PDF.
It'll be a canvas. You know, you do the questions, you write the answers, show me the working, all that fun stuff.
Okay, sounds good. Thank you. Thanks for
Okay,
that.
bye-bye. Any other questions? Then I'm off to my next class. Bye-bye, guys.